Suppose for example I have 4, right? I have 4. 4 can be written as a 2 power 2, right? 4 can be written as a 2 power 2, or in other words I can write it at reverse also. 2 power 2 can be written as a 4. Now you already know this concept, I am just explaining it to you once again so that we will take it forward in our problems. 2 square is nothing but 4. If I don't want this power 2 to be written on the left hand side, if I want to shift it on right hand side, the base on the left hand side remains the same and the base on the right hand side also remains the same. When the power on the left hand side comes to the right hand side, it becomes the reciprocal of the power. It becomes 1 by 2, right? It becomes 1 by 2. Similarly, for example, 16 is nothing but 4 square. 16 is nothing but 4 square. That 4 can be written as 16 power 1 by 2, right? 16 power 1 by 2. Suppose for example 4 cube is 64, right? 4 cube is 64. This 4 again can be written as 64 to the power of 1 by 3. If the power here comes to the left hand side, if the power here comes to the right hand side, or in other words you shift the power from one side to the other side, it becomes the reciprocal of that power, right? It becomes the reciprocal of that power. But can I also say that suppose for example I have 2 power 2, right? I have 2 power 2 which is 4. 4 is nothing but a constant. I have 2 power 3 which is 8. 8 is nothing but another constant. I have 2 power 4 which is 16. 16 is nothing but some other constant. That means you put some base, whatever you like, you raise it to some power, you put some base and you raise it to some power, you will ultimately get a constant quantity, right? You will ultimately get a constant quantity. This is the concept which you already know, but I want to take it forward for our problems which is already known to my students, right? Because this varieties of questions also have come in the examination sometimes, so let us not ignore any varieties, so that everything we will learn and we will make sure that in the examination we are prepared very well, right? Now see here, sir, see here, I am drafting the first question of today's session. Today's session is on Surds and Indices, which is my session 4. Session 4 Surds and Indices, first question, morning session, is what I am drafting right now. The question is, if 2 power A, 3 power B, 6 power C all are equal, if 2 power A is equal to 3 power B is equal to 6 power C, then your question is, then find C in terms of A and B, right? Find C in terms of A and B. Let us start with this kind of indices questions for the next 10 to 15 minutes, and then we will move on to our third question. Now listen carefully. Just 2 minutes before I told you a concept. 2 power A base to the power of some power, another base to the power of some power, again another base to the power of some power. If I raise any power for a base, it will ultimately result in a constant quantity, and they are saying that all these are equal in the question, right? Again I told you another concept just 2 minutes before. 2 power A is equal to K, right? 2 power A is equal to K. So 2 can be written as, if I want to shift this power A to the right hand side, it becomes K power 1 by A. 3 power B is equal to K. So 3 is nothing but K power 1 by B. 6 power C is equal to K. 6 is nothing but K power 1 by C. Now left hand side I have 3 numbers, 2, 3 and 6, right? Left hand side I have 3 numbers, 2, 3 and 6. What is the relationship between these 3 numbers? 2, 3 and 6. These are the numbers which I have on the left hand side. The relationship between these 3 numbers is nothing but 2 into 3 is equal to 6, right? 2 into 3 is equal to 6. That means K power 1 by A into K power 1 by B is equal to K power 1 by C. Left hand side, A power M into A power N, A power M plus N. It is K power 1 by A plus 1 by B is equal to K power 1 by C. Bases are same, equate the powers. C 1 by C is nothing but equal to 1 by A plus 1 by B. Find C in terms of A and B. If I take the LCM, it becomes AB A plus B divided by AB is equal to 1 by C. C will be equal to AB divided by A plus C. Right? C will be equal to AB divided by A plus C. Find C in terms of A plus A and B is the question we have found out. Because C does not have a numerical value given in the question, because A and B does not have a numerical value given in the question, it is coming in terms of variables itself ultimately. Exactly similar question. Exactly similar question with a small change. Question is, if 2 power x is equal to 3 power y is equal to 6 power minus z, then find the value of 1 by x plus 1 by y plus 1 by z. Now see here, in my previous question it was 2 power a, 3 power b, 6 power c. Instead of a, b, c, they have given it as x, y, z. It makes no difference. And the other change from the previous question is, for c the power is nothing but plus here in the first question. Here for z the power is nothing but minus. Right? It is minus z. That is the only difference. Same logic. All these things I will equate it to a constant called as k. 2 power x is equal to k. So 2 is equal to k power 1 by x. Same like my previous question. 3 is equal to k power 1 by y. 6 is equal to k power minus 1 by z. The relationship between 2, 3 and 6 is 2 into 3 is equal to 6. It is k power 1 by x plus k power 1 by x into k power 1 by y is equal to k power minus 1 by z. So if I put it on the left hand side, 1 by x, 1 by y, that will get added. Powers will get added if I ignore the bases. Here also power is minus 1 by z. Shift this minus 1 by z to the left hand side. 1 by x plus 1 by y plus 1 by z. This will give me value 0. The answer for this question is 0. Very, very easy question. Again, once you understand the concept behind solving the questions. Hello sir. Next question. Question number 3. We are solving that varieties of questions which involves powers or indices in it. If x power 1 by m is equal to y power 1 by n is equal to z power 1 by p, right, is equal to z power 1 by p, and xyz is equal to 1, right, xyz is equal to 1. Your question is, find the value of m plus n plus p, right, find the value of m plus n plus p. Now again the similar kind of model, same logic I will implement. X power 1 by m, y power 1 by n, z power 1 by p, all are equal and they all will be equal to some constant which I call it as k. So can I say that, so x value will be equal to, if I put this power 1 by m to the right hand side, it becomes a reciprocal of 1 by m, which is m. So it is k power m. Y is nothing but k power n. Z is nothing but k power p. But the very, very important condition which is given in this question is xyz is equal to 1. X is k power m. Y is k power n, z is k power p is equal to 1. 1 can be written as k power 0. Make the base same in each cases of left hand side and right hand side. A power m into a power n into a power p is a power m plus n plus p. So power will become m plus n plus p. Here the power will become 0. And that value is only what is asked in your question. Answer for this question is 0. The condition given in the question will matter a lot. If the condition is given, use the condition. If the condition is not given, if it is given in terms of numerical values like 2, 3 and 6 in my previous question, use the condition of or the relationship between those three numbers 2, 3 and 6. 2 into 3 is equal to 6. If you have any other relationship between those three numbers which will reduce the power or which will make the only the power to come and which will eliminate your base, use that condition or use that relationship itself. There is no rule that you should always use 2 into 3 is equal to 6 itself. Any other relationship, depending on that, you will get C in terms of A and B. Simple. I hope the first 3 questions of today's class should be very, very clear. First 3 questions should be clear, sir. Fourth question. Just give me a minute. I am checking for the fourth question. Fourth one. See this question again. A similar kind of question, but only thing is numerical values are involved in this question. Listen carefully. Your fourth question is if 5 power 1 by a instead of x power 1 by m in my previous question, now they are giving it as 5 power 1 by a. They are putting some numerical value for x, that is the base, is equal to 7 power 1 by b is equal to 35 to the power of 1 by c, right? 35 to the power of 1 by c. Your question is find c in terms of a and b, right? Find c in terms of a and b, right? This is the question. Find c in terms of a and b. Now listen carefully, sir. Same logic I will implement. This entire thing I will equate it to some constant called as k. 5 power 1 by a is equal to k. So 5 will be equal to this 1 by a power. If it goes to the right hand side, it becomes reciprocal of 1 by a, which is a. 5 is equal to k power a. 7 is equal to k power b. 35 is equal to k power c, right? 35 is equal to k power c. Now I have three numbers on the left hand side, 5, 7 and 35. The relationship between 5, 7 and 35 is 5 into 7 is equal to 35. So it is k power a into k power b is equal to k power c. Bases are same, equate the powers. So it is k power a plus b is equal to k power c. A plus b will be equal to c. Find c in terms of a and b is the question, and that is what exactly we have found just now. We have found c in terms of a and b. Very easy if you get this kind of questions in your exam, because the three numbers whatever will be given, two numbers will be equivalent to the third number in some or the other case. It need not be multiplication always. Question number 5. This question and this question, similar model. In fact, all the 4 questions are similar model in fact. Question number 5. Fifth question of today's morning session. Question number 5. Everywhere we took whole numbers. Let us take a decimal. 20.351 to the power of a. 2.0351 to the power of b. 10 power c. All these are equal. If this is the condition, then find the relationship between a, b and c, right? Find the relation between a, b and c. This is your question. I believe the idea is clear. If 20.351 to the power of a, 2.351 to the power of b and 10 power c all are equal, find the relationship between a and b. Now say a, b and c, same logic. Equate this entire thing to a constant called as k. So 20.351 will be equal to k power 1 by a. 2.0351 will be equal to k power 1 by b. 10 will be equal to k power 1 by c, right? This is what I can understand from my first statement which is given in the question, right? 10 will be equal to k power 1 by c. Now see here, sir. Can I write it like this? Observe carefully. Think logically. Can I write it as this 10 is nothing but 20.351 divided by 2.031. This will be equal to 10, right? This will be equal to 10. That means 20.351 divided by 2.031. The division or the quotient or the division of these two values is nothing but my third value 10. Similarly, division on right hand side is k power 1 by a divided by k power 1 by b is k power 1 by a minus 1 by b. Right hand side of this value is k power 1 by c. So you need to get a and b in terms of c, or relationship between a, b and c. 1 by a minus 1 by b is equal to 1 by c. Very easy. Do not worry if they give you the decimal values. What is the difference in this question? There is no difference compared to our previous question. If I divide this value by this value, I will get my another value which is 10. Right hand side also divide. That means this value divided by k power 1 by b should give my right hand side of another equation which is k power 1 by c. Bases are same, equate the powers. Simple. I hope the idea is clear, sir. Now listen carefully, sir. Again a very important module. We have discussed these varieties of questions in our second session on Surds and Indices, but I will take it forward for multiple questions in this class also again. Listen carefully, sir. First of all, let us take few examples, 2 to 3 examples for our understanding, and then let us take it forward for our problems. Now listen carefully. Suppose for example, I have a question 1 by root 3 minus root 2. I want to rationalize it. Easy questions we will start with. First 2 to 3 problems, easy questions. 1 by root 3 minus root 2, I want to rationalize it. Now, we know that a minus b into a plus b is equal to a square minus b square, right? Is equal to a square minus b square. That means I have a minus b in the denominator. I want a plus b to be in the denominator so that I can use that property. If I multiply by root 3 plus root 2, if I to a plus b, a square root 3 whole square is 3 minus b square root 2 whole square is 2. It is root 3 plus root 2. This is how. Don't use all these methods. Directly write the answer within one step itself, which I taught you also in my second class of Surds and Indices. Can I say that this is 1 root 3 minus 1 root 2. The coefficient of Surds in the denominator is 1 in both the case. If that is the case, directly subtract these two values without square root. That means what is 3 minus 2? 3 minus 2 is 1. That should be the denominator. If the denominator is 1, it makes no difference whether you write the denominator or do not write the denominator. Now numerator will be, because here you have minus, numerator it will become plus. And whatever the term which is there in the numerator, multiply with that. The term which is there is 1. So multiply with that 1. Right? Suppose for example, 2 more questions for your better understanding. Suppose I have root 3 minus root 5 minus root 3, my numerator is 2 for example. Don't waste your time and simplifying by writing everything into all those things. Directly try to write the answer. Root 5 minus root 3 is 1 root 5 minus, so denominator also will be 1 if it cancels out. So root 5 minus root 3 will become root 5 plus root 3. I believe the idea is clear. Our previous sessions, right? I am just making you to revise for a couple of minutes so that it will be clear for you. Suppose for example, I have root 7 minus root 3, and here I have something called as 2 for example. This can be written as 7 minus 3 is 4. That 4 will come in the denominator directly. No need to write it as multiply by root 7 plus root 3, divide by root 7 plus root 3, apply a square minus b square. Don't use all those methodologies. So it is that methodology is what we are using, but don't write it in your examination hall. 7 minus 3 is 4. 2 by 4 is 1 by 2. Directly write the denominator 2. Numerator will be root 7 plus root 3. Now, this is the concept of rationalizing the denominator. This is one of the concept what we learnt to solve our problems very easily and fast. Another concept what we have learnt is finding the square root of a surd, right? Finding the square root of a surd. Suppose for example, square root of 19 plus 8 root 3. Again 2 examples before we start with our problems. Square root of 19 plus 8 root 3 is what we need to find. For example, can I say that we always love to use this notation square root of a plus b whole square, because it will ultimately give me a plus b. Square root and square will cancel out. Square root of a minus b whole square will ultimately give me a minus b. That means I am very fond of these two notations, a plus b whole square, which is a square plus 2ab plus b square, and a minus b whole square is a square minus 2ab plus b square. That means, can I say that this 2ab, this 2 is very important for me. I don't have 2 here, I have 8 here. So make it as 2 into 4 and write it as root 3. Remaining terms write it as it is. Right? Remaining terms write it as it is. Now think logically, sir. This is root 3. This 4 also write it as root of something. 4 is nothing but root 16. Observe carefully. If I add these two terms, if I add these two terms, what is 16 plus 3? 16 plus 3 is 19, and that is my constant term which is given in this question. 19 is the constant term, so you can directly write your answer as root 16, which is 4, and root 3, write it as root 3 itself. If it is plus here, write down plus. If it is minus here, write down minus. Square root of root 4 plus root 3 whole square, which is nothing but 4 plus root 3 itself. Right, 4 plus root 3. Directly you can write those answers which I told you with multiple questions in my second class of Surds and Indices. Right, I am just explaining you 2 to 3 examples because there might be new students, or there might be students who might have forgotten what we have discussed on the other day. Right, suppose for example, tell me the answer for this. 4 plus 2 root 3 square root. Square root of 4 plus 2 root 3. Directly you can write, because 2 is already present. This is root 3 into root 1. 3 plus 1 is nothing but 4, which is my other constant term. Direct answer is root 3 and root 1. Because it is plus here, write down plus. Answer is root 3 plus root 1. Very fast you can tell the answers for these varieties. Right, answer is root 3 plus root 1. Suppose for example, I have a question. This is nothing but 7 plus 4 root 3, and I want to find the square root of it. This 4 can be written as 2 into 2. Right, 4 can be written as 2 into 2. Now this 2 can be written as root 4. Right, this 2 can be written as root 4. So it is 2 into root 4 into root 3. Check it out. This 4 plus 3 is nothing but this constant term 7. Because I am getting that constant term, directly write the answer as square root of 4 and square root of 3 with plus. Answer is 2 plus root 3. Getting the idea, sir? Answer is 2 plus root 3. Very, very fast I want my student to understand these logics, so that the same logic can be extended for some higher level questions. Getting the idea? Some higher level questions. Now you might get a doubt. This doubt also we discussed in our second class. Sir, 8 can be written as 2 into something, because 8 is an even number. 2 can be written as 2 into something. 4 can also be written as 2 into something. What if it is not an even number? What if I have an odd number? Right? What if I have an odd number? That also we discussed in our class earlier, sir. This is square root of 38 plus 5 root 3. Now I have 5, which is an odd number which cannot be written as 2 into something unless I will get a fractional value. But I definitely want that 2, because I want to make use of a plus b whole square or a minus b whole square notation. So what I will do is, inside the square root, I will multiply this by 2. This becomes, I am writing one problem step by step for your better understanding. Inside the square root, I will multiply and divide by 2. Square root of 2 is 1 by root 2. Take it outside. You are left with 2 into 38, which is 76. 2 into 5 into root 3. Right, 2 into 5 into root 3. 2 into 5 into root 3. Now same logic I will implement once again, sir. Same logic I will implement. This 5 should be written as, this is under the square root, in fact. Right, this is under the square root. 5 should be written as square root of something. Right, 5 should be written as square root of something. Square root of 25 is nothing but 5. Right, square root of 25 is nothing but 5. But think logically again. Square root of 25 is 5, but 25 plus 3 is not 76. That is also very important. So what I will do is, square root of 25 into square root of 3. It is square root of 75. Right, square root of 75. So I will write it as 76 plus 2 root of 75. That 75 I will write it as 75 into root 1. Why? Because 75 plus 1 is nothing but this constant 76. Directly now I can write the answer as, this is 1 by root 2, which is into root 75 into root 75 plus root 1, and root 75 can be further expressed as 5 root 3. 5 root 3 plus root 1 whole by root 2. This should be the final answer. If it is not an even number here, express it as even number by multiplying the required term inside the square root. All these things we have discussed already in our classes, which will make our problems so easier. I believe that the idea is clear, sir. If x is equal to root 3 by 2, once you understand these varieties, the problem solving is never a difficulty. If x is equal to root 3 by 2, then square root of 1 plus x plus square root of 1 minus x divided by square root of 1 plus x minus square root of 1 minus x. I need to find this value, right? I need to find the value of this. Now, do not waste your time by multiplying this rationalized term here, writing that term, dividing by the same term, and then finding out, simplifying all those things. I told you just 5 minutes before, square root term is coefficient is 1 in the denominator. Here also it is 1. When if that is the case, directly subtract the denominator. 1 plus x minus 1 minus x. So you will be left with 1 and minus 1 will get cancelled. You will be left with x plus x, which is 2x. Directly write the 2x in the denominator, and numerator, this term, if it is negative, it should become positive in the numerator. Already the same term is written positive. Another term you are writing positive. That means already a is present in the numerator. You are writing another a. So it is a plus a into a square, or in other words, this bracket term whole square in the numerator. Apply a plus b whole square. A square is nothing but root of 1 plus x whole square, which is 1 plus x. B square is root of 1 minus x whole square, which is 1 minus x, plus 2 into ab. A is root of 1 plus x, b is root of 1 minus x. 1 plus x into 1 minus x is a plus b into a minus b. A square minus b square. This is nothing but root of 1 minus x square, right? Simplify it right now. It is very easy to simplify as of now, because x and minus x will cancel. 1 plus 1 is 2, and here also there is a 2. 2 common factor will cancel with this 2. You are left in the numerator with 1 plus root of 1 minus x square whole thing divided by x, and x value is given in the question as root 3 by 2. It is 1 plus root 3 by 2. X square is nothing but root 3 by 2 whole square, which is nothing but 3 by 4. What is 1 minus 3 by 4? 1 by 4. What is the square root of 1 by 4? 1 by 2 divided by root 3 by 2. Your final answer after taking the LCM is 3 by root 3, which is nothing but root 3. After LCM, this 2 will cancel out. Answer for this question is root 3.